Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox. I'm titling this one Minimum Inlet Grate Length. So we're going to be using the calculator called Curb and Gutter Analysis to determine the minimum inlet grate length given the grate type and the grate width and a bunch of other data. All right, so let's go ahead and bring up the problem statement. Here it is. Find the grate length, that's the longitudinal length of the inlet grate. And our requirement is that the efficiency needs to be at least 70%. Okay, so we've been given some gutter and inlet data shown here. We also have some design storm data. So typically a flow rate will be provided, but in this case, we have a design storm data. So we're going to have to determine the peak flow rate from the design storm data, use that peak flow rate in the curb and gutter analysis. We have a front view and a profile view just to demonstrate the S sub X and the S sub L, the longitudinal slope down the street, as well as the cross street slope of 3% and 4% respectively. Okay. So we're going to be using these numbers once we input data into the calculators. The first calculator we're going to use is actually the rational method analysis tool for determining that peak flow rate. After that, we'll use a curb and gutter calculator to determine that minimum grate length. All right, so I'm going to close that up. Back to the hydraulic toolbox. Calculators, I'm going to add a curb and gutter analysis, and then to calculate the peak flow rate from our design storm, I'm also going to add a rational method analysis. So that's this one right here. In fact, we're going to start with that. So I'll double click to open up the calculator. Notice that I am using metric units for this exercise. So if you need to switch, you can just select SI units metric here, or go up to units and click on SI units. All right, so let's enter our data. From the design storm data, the runoff coefficient is 0.73. The area is 2 hectares, and the rainfall intensity for the design storm was 20 millimeters per hour. So if you hit the tab button, it will compute the flow rate down here, and it says 0.1 CMS. And I sort of think this is a shortcoming of the program because any engineer would want at least 3 significant figures. And if it starts with a 1, you most likely want 4 significant figures, especially for an intermediate calculation like this. So just seeing a 0.1 CMS is very unsatisfying. I went ahead and did the math by hand outside of the calculator, and it is actually 0.0819 cubic meters per second. So that just rounded to 0.1 CMS in this calculator here, unfortunately. But we're going to be using 0.0819 CMS. All right, so open up the curb and gutter analysis here, and let's start entering our data. So the longitudinal slope of the road is 0.03. The cross slope of the pavement is 0.04. That's 4%. And then Manning's roughness value, we were given that is 0.016. The gutter width, it's starting me off at 0.61 meters. It's actually 0.6 meters, so almost. And then the design flow, this is the flow rate in CMS that we calculated using the rational method calculator, 0.0819. Of course, we got 0.1, but we're just using the refined version here. And then I can click on compute unknown. It gives me the width of the spread in meters, as well as some other hydraulic properties. All right, so that's cool for the gutters. Next, the inlet data. This is an inlet on the grade, so no percent clogging. The inlet type, this is going to be a grate inlet. And then the type of inlet we were provided is a P1 7/8-4. So there's lateral bars every 4 inches. All right, we were also given that the grate width is 0.6 meters. And then I'm going to tab off and I'm just going to say the grate length is 0.6 meters and click tab. Now this is the variable that we don't know. This is the variable that we're solving for. So I'm just going to start off with 0.6 for the grate length. And then I'm going to click compute. We're going to look at the criteria for efficiency and may most likely have to modify that grate length. So compute inlet data, and down below we have our data. So we have intercepted flow, bypass flow, approach velocity, and splash over velocity. And the efficiency is actually 70.5%. So I didn't realize that that was going to happen. It looks like we're already right on what we should be actually. So anyway, the minimum efficiency is 70%. Let's go ahead and modify that grate length a little bit and just make sure what we're looking at here for 70% is really what we have. Okay, so the grate length, let's go ahead and increase that to how about 50% more? I'll say 0.9 meters. We'll tab off and then click on Compute Inlet Data. Okay, so the efficiency increased to 73.7%. That makes sense. Let's decrease it now from zero point 0.6 to how about 0.5, and then I'll click on Compute Inlet Data. Okay, so that's now down to 67.2%. I think I just happened to select the exact right size, which was actually a little bit of an accident because some of my other numbers were switched. How about 0.58? So trying to get as close to 70% as possible. Compute inlet data. So that's 70.3%, 0.55. Compute inlet data. Okay, 0.693 now. So it's going to be basically between 0.55 and 0.58. How about 0.56? No good. 0.57. Compute, and we're good there. Now we do have a message that says that the approach velocity exceeds the splash over velocity, which is probably a concern, but I'm just looking at this efficiency here of 70%, and I'm happy with that. So that solves our problem. We have a great width here of 0.6 meters and then a great length of 0.57 meters to attain a efficiency of 70%. Now, in reality, you may not be able to get a great length this particular dimensions. If it's 0.6, there's probably 0.6 that's also available, or something a little bit larger, maybe in units of every half a meter or something. Just because the calculator gives you an answer doesn't mean that that particular product is manufactured and available for construction. So whatever number you get here for the great length, you'd probably just round up to the next available size for your inlet dimensions. All right, well, that was it for this exercise. What we talked about was finding the minimum grate length for our inlet grate to achieve an efficiency of 70%, which was determined using our gutter data and our hydraulic data, as well as the flow rate, which we calculated using the rational method calculator.